Hello everyone, let's discuss the concept of transformer core. So in this session I would like to discuss the significance of silicon steel. In coming session I would like to discuss significance of CRGO steel. So later we will conclude which type of material is required to design a transformer core. Okay, so in this session we have to discuss the significance of silicon steel. So the material required is what? Silicon steel. So electrical steel. So it is preferred in most of the machines. Preferred in most of the machines. Preferred in most of the machines. So why it is required for the core? For that we have to discuss some features of silicon steel. Why we need silicon steel? Features of silicon steel. So in that, first one is it is a ferromagnetic material. For this type of material the hysteresis coefficient is very less. That's why we need silicon steel. And second point is it offers high permeability. It offers high permeability, right? No. Which means what? It offers high permeability means what? That is low reluctance. If the value of reluctance is very less, obviously the flux path is very high, right? And for this type of material less excitation is required. Less excitation is required to set up required flux. This is third one. And fourth one is what? Magnetization is easier. Magnetization is easier and low hysteresis coefficient. So what is low hysteresis coefficient? So as magnetic reverses due to alternating flux, a power loss should take place. That loss should be very less, right? So these are the main features of silicon steel. So let us consider WH. Let us say this is hysteresis loss. So what is the empirical formula for hysteresis loss? Eta B max power x frequency and voltage. This is the empirical formula. We have to remember this empirical formula. This is the empirical formula. So where x is the hysteresis coefficient. So generally the value should be 1.25 to 2.5. The value of hysteresis coefficient is 1.25 to 2.5. So for silicon steel the value should be x should be equals to 1.6. If X is low, obviously hysteresis loss should be low. Clear? If X is low, obviously the hysteresis loss should be very low. So for silicon steel, the value of hysteresis coefficient is 1.6, right? Then here the question comes, what will happen if the transformer core is made of pure steel? Question is, what will happen if transformer core is made of pure steel? Then what is the answer? So pure steel is good conductor of electricity. Pure steel is nothing but good conductor of electricity. So what will happen? Before that, we know that supply voltage is responsible to get current. This current is responsible to get flux. This flux is responsible to get statically induced EMF in transformer, right? And one more important point here is this flux and this EMF both are alternating in nature. So because of statically induced EMF, due to high conductivity, there are circulating currents in transformer core. So because of due to high conductivity, there are more chances to get circulating currents in transformer core. So whenever we are having circulating currents in transformer core, obviously we are going to get more eddy current losses, which leads to get more eddy current losses. This is very important point. So we all know that conductivity is responsible to get eddy current losses. So due to high conductivity, that EMF is responsible to provide current. That current is nothing but circulating current, so which leads to get more eddy current losses. So how we can reduce that eddy current losses? So if we provide pure silicon steel, obviously the conductivity is more. Because of that, we have a current. That current is called circulating current. That current is responsible to get eddy current losses. So in order to reduce eddy current losses, we have to add some silicon to the steel. So in order to reduce eddy current losses, we have to add some portions of silicon to the pure steel. That's why we have to add some portions of silicon to the steel. That's why any transformer core is does not made up of pure steel. Some amount of silicon should be added. That is, in transformer core 4 to 5% of silicon is added to the pure steel. What is the value? 4 to 5% of silicon steel, sorry, 4 to 5% of silicon is added to the pure steel. But what is the important point? Note, silicon should be added without losing any magnetic properties of the core. Without losing any magnetic properties of core, we have to add some amount of proportion to the pure steel, but there are no chances to lose our magnetic properties of the core. This is very, very important point. So without affecting the magnetic properties of the core, we have to add some proportions of silicon to the pure steel to reduce the conductivity, to reduce the conductivity. So now we have clear idea why we have to provide some amount of proportion to the pure steel. If you provide pure steel for the manufacturing of core, obviously we have to get more circulating currents, which leads to we have to get more eddy current losses. So that's why we have to provide 4 to 5% of silicon steel to the pure steel to reduce the conductivity, which in turn reduce the circulating current, which in turn reduce the eddy current losses. Then again one question, what will happen if transformer core, or what will happen if we provide more silicon steel to the transformer core instead of 4 to 5%. So what will happen if you provide more silicon steel to the transformer core instead of 4 to 5%? What will happen? If we provide more silicon content to the transformer steel core material, what will happen? It will makes the core more brittle. So if we provide more silicon content to the pure steel, obviously the core of the transformer should be more brittle in nature, So that's why, which leads to it will makes the core more brittle, which leads to reduce the mechanical strength of the core. Which leads to reduce the mechanical strength of the core. That's why we have to provide only 4 to 5% of the silicon to the steel. If you provide more amount of silicon, obviously the core of the transformer should be more brittle, which leads to less mechanical strength. Then how can we reduce eddy current losses further? To reduce eddy current losses further, what will happen? Core of transformer must be laminated. So laminations are required to reduce the eddy current losses. The core of the transformer must be laminated. We have to discuss what are these laminations in future classes. So this is the significance of silicon steel. So if you provide more silicon steel, what will happen? The transformer core must be brittle in nature, which leads to less mechanical strength of the core. That's why we have to provide only 4 to 5% of silicon content to the steel. Then only we have to reduce the conductivity, which leads to less circulating currents, which leads to less eddy current losses. Somewhat eddy current losses are minimized. That's it. Later we will discuss significance of CRGO steel. Then we have to conclude which type of material is used to manufacture transformer core, whether it is CRGO steel or silicon steel. Thank you.